Hey guys, welcome to another episode of Two Data Detectives. Today, we're going to have a look at Mixtral of Experts by Mixtral.ai. Let's read this paper together, Mixtral of Experts, and it's about the Mixtral 8x7b model. Why do you want to know about this model? Because it's the new best open source model in the market. It is better than the last best open source model, Llama 2, in all these benchmarks, including mathematics, code generation, and multilingual benchmarks. Here's a good example of Mixtral solving a coding challenge in Chinese. So who trained this model? It's by a company called Mixtral.ai, and they're an AI company from France. So Mistral is the company's name. And Mistral's model is called Mixtral 8x7b parameters. And by parameters, we mean the weight of the neural network because Mixtral is a neural network model. Mixtral is a decoder-only model, and the reason why it's called Mixtral is because it's a sparse mixture of experts. What does that mean? Well, it's indicated in the name 8x7b. 8 means there are 8 experts, and each expert has been trained with different skills and they're good at different things. Each expert is a 7 billion parameter Mistral model. Well, how do these experts work together? For every token, it has access to these 8 experts, but there is a gating function which means that the model only chooses 2 experts to compute the output for this token. That means every token has access to the full 8 experts, 47 billion parameters, but at one time, only 2 experts, which means only 13 billion parameters, are active. So what's the benefit of having this mixture of experts? The first one definitely is the cost, because you only use 13 billion parameters at one time, so the computational cost is actually much lower than, let's say, 70 billion parameters. Followed by that is latency, because usually the more parameters there are, the slower the model is. And if you imagine, if you have access, you have the knowledge to all 47 billion parameters, but at one time when you compute, you only use 13 billion. That means you have the knowledge, but your model is much faster. Another advantage regarding latency is if you have multiple GPUs, this model allows you to have expert parallelism. What does that mean? It means that you can put one expert on one GPU and your routing function will just send those tasks to all these parallel GPUs. And that makes the model even faster. However, that poses a challenge in load balancing because you're routing the workload. In terms of output quality, this mixture of experts also has multiple benefits. They have shown great performance in multilingual benchmarks, long-range performance, and comparing to Llama 2 70b, they have shown less bias in terms of gender, profession, religious, and political ideology. Comparing to Llama 2 70b, it also has better parameter efficiency while having better performance in all these benchmarks. Mixtral only has 47 billion parameters, comparing to Llama 2 has 70 billion parameters. In terms of the license, Mixtral uses Apache 2.0 license, which is free for both academic and commercial use. Mixtral has a context length of 32K tokens. This is probably what most people need to know about Mixtral, but if you're interested to know how it actually works and learn some more interesting facts about Mixtral, keep watching. First, let's have a look at how outputs are computed. What does it mean by sparse mixture of experts? Well, have a look at this figure from the paper. When the inputs come in, there's a router function which is called gx, and the reason why it's sparse because it only picks 2 of the experts, which means it's zeroing the other 6 parts of the network. So once the 2 experts are selected, you multiply that by the gating function weight, which is a softmax, and you add them up together, so it's the sum of this multiplication. Now let's have a look at Mixtral's benchmark performances. The Mixtral paper said they compared Mixtral to Llama on these benchmarks. You can see that Mixtral outperforms Llama on almost all of these benchmarks, especially math and coding, which agrees with what they mentioned before. What you can see that Llama slightly outperforms Mixtral is in comprehension and AGI eval. In this detailed table they gave afterwards, you can see that Mixtral does outperform Llama in almost everything except for HelloSwag and Wino Grant and Tried QA, but only slightly. Now, I think some really interesting findings this paper mentioned is from the routing analysis. They look at what expert has been selected by the router for each token or topic. The first very interesting finding is that they've observed no obvious pattern in the assignment of experts based on topics, well, except for mathematics. As you can see from this graph, every color is a topic, and you can see these colors are almost evenly distributed, except for yellow bars, DM mathematics, so these two here. Another finding is that some words always get routed to the same experts. For example, in here, every color is an expert, and you can see words like self, question, and even indentation are always routed to the same experts. This tells us that the selection of experts appear to be more aligned with the syntax rather than the domain. The last very interesting finding is that consecutive tokens are often assigned the same experts. Look at this table. Pure random selection for first choice is 12.5%, and for first or second choice is 46%. And these numbers obviously are much higher than random. In summary, Mistral 8x7b is a very powerful model with some really clever design. It outperforms Claude 2.1, Gemini Pro, and GPT 3.5 Turbo, and Llama 2 70b on many of the benchmarks. I hope you enjoy reading this paper with me. I'll see you in the next video.